Hello there and welcome to Lower 6th Maths AL. This is the Applied Practice Paper H. Here on question 6, a variable acceleration question. So a sled is moving down a steep hill in a straight line. At time t seconds, the acceleration of the sled in a meters per second squared is represented by 1 over 500 bracket 20t squared minus t cubed from 0 to 20. When t equals 0, the sled is at rest at the top of the hill. Find the distance the sled travels in the first 10 seconds of motion. So in this case here, we're looking for a distance and all we're given is acceleration. So what we're going to have to do here is use those formulas that help us get from distance to velocity to acceleration, or more precisely, using those in reverse. So remember that velocity is the change in distance, so this is differentiation. Acceleration is the difference in velocity, so this is differentiation to get from v to a. So if we want to work our way backwards, we're going to have to integrate acceleration to get velocity and integrate velocity to get back to distance travelled. So the first thing we need to do here is to find v, which is going to be the integral of 1 over 500, I'll bring that to the front, of 20t squared minus t cubed dt. And this here is going to be 1 over 500, increase the power by 1, divide by the new power, 20t cubed, divide by that 3 that we've just made, and we get that. Increase the power by 1 here, that's a 4, and divide by that new 4 that we get here. And we mustn't forget to plus c. Can we find c at the moment? Well, let's look here. We've got d, when t equals 0, the sled is stationary at rest at the top of the hill. So in this case here, when t equals 0, v is going to equal 0. So in this case, c is just equal to 0. So the next thing we need to do here is to work out s by integrating the velocity. So what we're going to get here is increase the power, so integrating our velocity, and remember that c was 0, so I don't need to add anything else at the end there. So what we're going to get here is 1 out of 500 bracket, increase the power by 1, so it's now a 4, divide by the new power and we get 12, minus t to the power of 5, divide by the new power and we get 20 on the bottom there. And we must remember as well to plus c, let's call it c2 here. Now assuming that when we are when we're at a time of 0, we want to find how far it travels in the first 10 seconds, we're going to assume here that when t equals 0, we've not travelled any distance. So in this case here, we're going to get as well c2 equals 0. So our formula for distance travelled is quite simply 1 out of 500. Let's try and simplify what we can here. So divide through by 4 on the top and bottom and we get 5t4 over 3 minus t5 over 20. And plus c2, but c2 is 0, so that is our formula for distance travelled. Okay, what we need to do now is find the distance travelled in the first 10 seconds. So plugging in t equals 10, and what we're going to get here, plug that into your calculator, and you get s, t equals 10, we're going to get s equals 70 over 3 meters. Okay, and in this case here, we could round that to 23.3 recurring. We'll stop it there, 23.3 meters. Okay, that's 5 marks for that question.